Okay, this is a problem with two different parts, two different accelerations, so we can use our equations of motion with constant acceleration as long as we're careful to separate the problem into two parts. Let me start with the diagram. So the car is accelerating up a ramp that is inclined 22 degrees with respect to the horizontal. Let's see, it starts from rest, accelerates up a 75 meter long ramp, so the ramp is 75 meters long. And then once the car reaches the top of the ramp, it has some final velocity v, which is going to be the initial velocity v naught, right? Part 1 ends there, and part 2 of our motion begins there. Final velocity from part 1 is equal to the initial velocity for part 2. And that initial velocity has an x component. It goes like that, let's say. It's going to have an x component and a y component. V naught x and v naught y for part 2. The car is going to travel up a ways, reach some maximum height, and then fall to the ground. Now, we want to know what maximum height above ground level does the car reach, so we need to know the y displacement in part 1, and we need to know the y displacement in part 2 and add those together. We also want to know what is the car's velocity v when it reaches its maximum height, the magnitude and direction of its final velocity. Alright, so now that I've drawn the diagram for you, then if you haven't already done the problem, now's a good time to pause the video and work out the problem on your own. Alright, well, I'm going to go ahead and do part 1, which is the part on the ramp. Now, I could divide this into x and y components. I could say that delta x is 75 cosine 22, v naught is 0, the acceleration is 14 cosine 22. I don't think we really need to do that. I think it's easier, when you're doing a problem where it's moving in a straight line, the best thing to do is to take your coordinate system along that straight line, so you don't have to do sines and cosines. Now, when it's in free fall and it's going on a curved path, sure, you got to do x and y, but if it's going in a straight line, take advantage of that. So along that line of motion, we have these quantities. It goes 75 meters with an acceleration of 14 meters per second squared, and it starts from rest. I'm going to go ahead and find the final velocity using the equation that doesn't have time in it. Okay, now when I take the square root of this, I get 45.83. I'm going to take the positive value. My sign convention in this problem is that it'll be to the right is positive and up is positive. And so generally along the ramp that'll be positive as well. So my final velocity for part 1 is 45.83. That's the initial velocity for part 1, or for part 2. So v naught for part 2 is 45.83 meters per second. So we're going to keep that in mind for part 2. I guess I also need to know delta y for part 1, the displacement here, delta y. And since it's moving in a straight line, I can say that delta y1 is equal to delta s sine 22, which is 28.1 meters. Alright, can do that because we're moving in a straight line. So now let's do the free fall motion. Part 2, we're going to take the part of the motion where the ramp goes, where we go from the end of the ramp to the maximum height. So I'm going to split this up into x and y. At this point, you should pause the video and try to fill out this table with all the things that are given and all the things that are unknown. Put question marks. If you haven't already done that, pause the video now and fill in this table for yourself. right? So for this part, we have an initial velocity of 45.83 that is directed 22 degrees above the horizontal. So I've got my x and my y. So V naught, so my delta x I don't know, but my V naught x is going to be V naught cosine 22, which is 42.49 meters per second. That's going to be my final velocity as well, because my x acceleration when I'm in free fall is 0. Delta y for part 2, I don't know. V naught y is going to be 45.83 times the sine of 22, which is 17.17 meters per sec. Since we're going to max height, final y velocity is 0. That's a hidden assumption in this problem, and the y acceleration is minus 9.8. Right? Remember that negative is important. V naught y is positive because it points up, and that's consistent with our sign convention. The acceleration points down, so that's negative, consistent with our sign convention. Time is unknown. Let me go ahead and get the max height out of the way. I'm going to use the equation that doesn't have t in it and solve for my y quantity. So Vy squared I get 0 is equal to V naught squared plus 2ay, and so delta y for part 2 is 15.0 meters. So that means that the total maximum height is equal to delta y for part 1 plus delta y for part 2. That's 28.1 up here and 15.0 down here. So 43 meters, rounding off to 2 significant figures, since the problem only had 2 significant figures. And then as far as the velocity goes, well, hell, we already solved that, right? Our Vx, our final velocity at max height, is 42.49. The y component is 0. So the velocity at max height is just, rounding off, is just 42 meters per second, and it's in the plus x direction. Don't need to do any trig for that. And we're done.